Right, let's get started. So my name is Alejandro Ferreira. I'm a senior solutions architect at Quorum, and I want to welcome you to our webinar today, Modeling CCS Development Concept in Europe, Insights from the IGME, or the Spanish Geological Survey Pilot Strategy Project. With me today, I have Dr. Paula Cantelli. She's a mining engineer with more than 20 years of experience in techno-economic evaluations, uncertainty analysis, and geological storage. Right now, she is the head of the Institutional Relations and International at the official Spanish Geological Survey. And she will tell us more about the different European initiatives in the CCS space. And myself, Alejandro Ferreira, I'm as I told you, Senior Solutions Architect at Quorum. I am helping Quorum customers to leverage technology in the energy sector. I will be the webinar's moderator and Paula's interviewer today. Quick webinar agenda. So we will start with just a very short market trend, okay? Navigating the market disruptions. That will take around 10 minutes. And then we're going to start the interview with Dr. Paula about modeling decisions and the experience using one of the Quorum's software. And at the end, we're going to have a short Q&A session. So as I mentioned before, please feel free to drop your questions in the webinar software, go to webinar software, okay? So talking a bit about the market trend. So in the big picture, so what we're seeing is that 2026 seems to be signaling the end of the pilot era for CCS. We are moving from laboratory proof of concept to industrial infrastructure reality. The market value is estimated at roughly 5.3 billion in 2026. So while growth is aggressive from 11 to 25% annual growth rate, it's important to note that even at the 100% of project completion, we are currently undershooting the International Energy Agency net zero requirement of 1 gigaton per year removal by 2030. In terms of current capacity, as 2025, the global capture capacity was at 50 megatons per annum. And as of early 2026, the operational capacity is around 64 megatons per annum. But the pipeline for 2030 is projected to be around 5 times higher. So the key point here is that the market isn't just growing, it's professionalizing, okay? It's maturing very well and rapidly. In terms of regional market dominance, what we see is that North America, basically the US is the undisputed leader, holding around 60% of the market share. What they call the Section 45Q tax credit is the engine, really. So now offering up to $180 per ton for direct air capture and $85 per ton for the point source storage. Note that while the policy shifts in early 2026 created some uncertainty, 45Q tax credit has largely been retained, which is preserving the investors' confidence. In Europe, this is the fastest growing region. So the European Union is pushing this with what we call the Net Zero Industry Act, which establishes a carbon storage target of 50 megatons per year of injection capacity by 2030 and 250 megatons per annum by 2050. The North Sea is being the epicentric of this activity. In Asia Pacific, the big potential, of course, is with China and India. China's Shengli oil field and India, a new hub in Visakhapatnam Pharma City, shows that APAC is rapidly closing the gap by focusing on high volume industrial clusters. Okay. In terms of key technology trends and disruptions, so There's a shift to hub and cluster. So this has to do with the logistics of the carbon. So instead of every factory building its own storage, they join a hub and share transport and storage infrastructure. So projects like the Porthos in the Netherlands and the East Coast cluster in the UK are good examples. This is also known as SaaS, not software as a service, but now it's storage as a service model. This is why the Northern Lights project is a blueprint here in Europe. It's the world's first commercial CO2 transport and storage company, right? The direct air capture is scaling. The Stratos projects in Texas, which is a giant to watch. It's on target for Q2 2026 startup. It is roughly 14 times larger than any current similar plant. In the past, we mostly use CO2 for enhanced oil recovery, right? But today the trend is towards dedicated geological storage. And we are looking at deep saline aquifers, massive saltwater sponges kilometers below the earth that allows to inject safely and store the CO2. So it's a bit of the subsea and onshore storage innovation. So in terms of industry leaders and strategic moves that we're seeing, the oil majors, of course, these companies are the ones with subsurface expertise, 50 years of enhanced oil recovery, and they are used to these massive, scale projects. We saw, for example, the strategic acquisition of ExxonMobil's of Denbury as a move to control the largest CO2 pipeline network in the US. 1.5, a subsidiary of Oxy, is leading direct air capture company, deploying large-scale technology to remove atmospheric CO2 and store it in geologic formations. Of course, Equinor, Shell, and Total Energies jointly developing the Northern Lights project, the world's first open source cross-border CO2 transport and storage network. There are some other technology pure plays. For example, the SLB and Aker carbon capture joint venture formed in 2025. They are focusing on single modular units that can be plugged into mid-sized industrial plants. Also, Mitsubishi Heavy Industries is doing Europe's first post-combustion carbon capture plant at the ENI's Casalborsetti, natural gas plant near Ravenna in Italy. Another important or key thing here are the corporate buyers. The giants such as Microsoft, Amazon, Airbus have already pre-purchased like 80% of the capacity for many upcoming plants, which is vital to keep the investments in these projects. Also, we have to notice the barriers to scale. So we can start by some infrastructure deficit. So the emitters are hesitant to invest without some storage certainty, while the storage operators need firm capture commitments, right? So it's a bit of the chicken and egg problem. There are some policy gaps and public issues. The permits move slow. It can still take years basically to issue. And due to the current political environment, we might face some policy shifts that increase the uncertainty. Capturing the carbon takes a lot of energy, as we know, often shrinking the plant efficiency by 15 up to 30%. There is the cost reality factor as well. So costs are higher than expected. Current rates can range from $50 to $300 per ton, depending on the case. And sometimes, of course, they exceed the carbon credit. Particularly in Europe, there is a lot of complexity around regulation, and we don't have as many as incentives as in other places, which makes it even more difficult. There is also an imbalance in subsurface data knowledge in Europe. So there is a lot of data, but the majority comes from the North Sea. So the CCS is moving really fast, but south and east of Europe, we don't have much subsurface data, which make it a barrier to scale up. Okay. So the success of 2026 to 2030 period depends on the value chain alignment, really. So it's getting the capturer, the transporter, and the storer to sign long-term contracts at the same time. So CCS projects are like, you can think it as a high-speed rail network. You cannot just build the train, which would be the equivalent to the capture plant in this example. You need also the tracks, right, which would be like the pipelines, and you also need the station, which would be the storage, and all of them have to be finished on the same time for the first passenger to take a ride, let's say, right? So it needs to be aligned. There's some alignment that is required there. So to talk more about how these work and how projects are studied, evaluated, and piloted, we brought a real expert, Dr. Paula Cantelli, who will help us to understand more about this through her work at the Spanish Geological Survey. Hi, Paula. Can you hear us, Paula? I cannot hear you. I still cannot hear you. Maybe check. Yes.
Could you hear me now?
Yes, now I can hear you.
Thank you. There have been a lot of problems to go into.
No worries. All right. So how are you today? You're speaking from Madrid, right?
Yes, I'm in Madrid, in the head office of the Geological Survey of Spain here in Madrid. A very sunny day, by the way.
Excellent, excellent. All right. So could you introduce yourself a little bit and talk about your background for the audience?
Yes, you have introduced me before very well, but just to be focused that I have been working on the oil and gas business during 10 years, and that is very important because all the learnings from the oil and gas I can apply now to the CO2 storage side. I came back to Spain 10 years ago, and from then I have been focused on the CO2 storage. Here from the Geological Survey in the international projects and also in national ones.
Good, good. And what is the Spanish Geological Survey? What do they do?
There is a public institution. We have more than 175 years, and is the national center of reference in the earth science. We are focused on the subsoil, in the groundwater, geological storage, geoenergy, natural hazards, and focus on scientific and technical advisor to the administration. We have also our research pillar and also the dissemination and information repository for the citizens and for public use.
Interesting. And can you describe particularly your work at the Spanish Geological Survey?
The CO2 storage is one of the strategic lines of the Geological Survey for many years. In fact, we have the National Atlas of CO2 storage that we built in 2009, 2011, and now we are working on the European Atlas of CO2 storage potential in the GCU project. From more recently, in around 2020, after, well, I don't know if you know, that there was a lack of interest on the CCS during a long period, but came back at the end of the 2018, 2019, and we proposed together with our colleagues from France and Portugal and others in Europe to a European project trying to define potential for clusters in the different countries. Here in Spain, we have been focused on study a cluster around the chemical area of Tarragona and Barcelona, as you are there, telling you. And it was very good exercise because it was first time that we did it in Spain and the results were very promising. We did the same also for the cement industry to identify, but this time focus on the economics, on how is the cost to store from this industry in the nearby area. And that can move up to this pilot strategy project and link with something that you said before that is very important, the imbalance in the knowledge of the subsoil here in Europe, because around North Sea, you know, the oil and gas industry, there is a lot of data, but not in the south and east of Europe. And that is the idea of the pilot strategy. We have been focused on the characterization in detail in one specific storage site and study the potential for a pilot and commercial scale up. Or in our case here in Spain, that is the same exercise in France, in Portugal, and with a little lower detail also in Poland and in Greece.
That is good news. Great to hear. Any particular region that was more promising than other, or similar potential, let's say, between the countries?
We select this in France. From the previous project, we identify 8 countries in Europe, and in this pilot, from this, we select 3. That was France, Portugal, and Spain. Because of the level of detail and the interest of the industry, mainly.
Of course. All right. And so for all these, let's say, studies and work that you are describing, which looks like a, heavy and, extensive study, how is technology, particularly software in this case, helping you with all this work?
Generally speaking, as we need to understand what happened in the subsoil, that is, in our case, to understand the geology, modeling the geology, the uncertainties around the information, the reservoir behavior, understanding, and so on. And with this, in the case of defining this cluster, specifically talking about the CCS, defining the cluster or identifying the potential for a specific case, we need other type of software, the economic evaluation for doing this exercise. Right.
And how did you end up finding about Quorum software? Because, well, people in the audience might say, how this collaboration between the geology survey of Spain and Quorum happened, right? How did you find about us?
That is, I really like this story because it was unexpected to me. When we wrote the proposal for the European project, sincerely, I wrote, I'm the leader of the work package 4, that is exactly the implementation of the CCS around each of these reservoirs. So identify, capture, transport, the storage site, and doing the techno-economic evaluation. So writing the proposal, I know Petroviar from my time in the oil and gas business, and I write it thinking on Petroviar. But I ask, and the license is very expensive for us because we are a public institution. Right. But we explain to you, your colleagues, our plan, the idea, the objectives, and they were very, very kind and supportive. We have an agreement initially for 1 year, and now it is the 3rd year. So I'm very grateful.
That's good. Good to hear. Good to hear. Yeah, for the people in the audience that might not be familiar with Petroviar, Petroviar is an integrated simulator software designed for oil and gas and energy projects, particularly those with large investments and significant risk and uncertainties. that allows you basically to model different scenarios and compare the trade-offs between them, right? And precisely do these techno-economical assessments. And particularly in the last, I would say, 3, perhaps 4 years, the development effort is focused on precisely sustainable development, CCS capabilities, and geothermal as well. And why did you choose PetroVR particularly? Were any specific capabilities that you were aware or that you discovered that could really help you in your project?
PetroVR is a tool that you can combine the knowledge about the subsurface, the storage side, but also transport and capture. And all of these can be analyzed economically, an economic model, deterministic and probabilistic. And when starting a case with so few data and so high uncertainties, the possibility of including these uncertainties along the full channel is fantastic. And there is something that I really, really like is that uncertainty and the probabilistic analysis can be included also in the timing, in the schedule. Because as you say before, the regulation, we have a lot of regulation about the CO2 storage or the CCS, and we need to combine, and there are a lot of permitting in the process that can give us delays and that have a huge impact on the economics. So these combinations of can understand the uncertainties, combining not only for the storage itself, transport, building, and so on, also in the timing, is incredible. For me, PetroVR is like a Lego pieces that you can do a model as simple as you need or as complex as you would like. And from the beginning of, from the exploration phase, from the beginning, and you can move also along the maturation of the project, also in the development phase. So it's very flexible. I really like.
That's good to know. Good to hear. What do you think is, you know, at the end of the day, what is the value that PetroVR is bringing to the geological survey?
Specifically in the pilot strategy, we could, we have used it from the initial phase when we need to define a potential development, because we select different cases. We can analyze individually, but also compare the economic results from them and the timing and the impact of them, to have different scenarios and the possibility of evaluate them and to take the best one or the optimum one, and improve or work only on this and understand all the economics for this case, the sensitivity analysis, both probabilistic, deterministic, give us a very good picture for the decision taking that at the end of this specific project is to go ahead or no for a pilot, for a permitting, in that case for exploration permit.
Right. Yeah, and it's a critical point, right? Where
Exactly.
you have to be very careful how you, when you make a decision, right? Because you don't know exactly, like a minor error could extrapolate, right, in time and become a large effect. Yeah. So yeah.
And it's another point that I didn't mention, and I would like, because the project will have a very enormous team about the geology, the dynamic simulation, about the risk, about the many different, and in PetroVR we combine all of this knowledge. So we ensure that everybody is participating in the building of the model, and we ensure the consistency on the all different disciplines. So the results are also analyzed with them, coming back and explain their work, the impact of their uncertainties, how can we improve the knowledge, results.
Right, right. That's a good point, because PetroVR really helps to integrate these different inputs for multiple disciplines, as you're mentioning. And by the way, out of curiosity, between how many like disciplines or different team members do you collaborate normally in the institute?
In this project in particular, I think that only from here, from the geological survey, we are 40 plus the people of the Spanish team. All of us have been working in this. We are a geological survey, CIEMAT, this other public organization, and Repsol. The three have been working, and in total, perhaps we have been working around 60, 70 people along this 5 years project. Knowledge, understanding, defining results, and so on. Yeah, it's a huge project. It's a very interesting one.
Definitely, that's great. That's great. A final thought: do you foresee using PetroVR in a future project?
I will love to. I think that is very, very, very useful. Very useful for understanding, really understanding the uncertainties and the key elements for decision making. Yes.
That's great. All right. So we've been discussing quite a bit. I think it's time for a bit of Q&A from the audience. So let me quickly check if we have any questions here from the attendees. Quickly double check. All right. So so we have one question here. Which data types and subsurface inputs were most critical for estimating storage capacity and injectivity in the pilot strategy models?
That was evaluated in the reservoir simulation. Yeah. And in our case, we have potential compartmentalization. So our main limitation was about the pressure. So pressure. The question is that we have, because we need to understand if really we have this compartmentalization or not. And in the worst case, assuming that it is, the limitation is the pressure more than the injectivity itself.
All right. I have another question from the audience. From your pilot strategy experience, what practical recommendations would you give teams starting PetroVR-based CCS concept models in a new region?
To start the model with PetroVR, first, what we have done in the pilot strategy was to have clear the objective. Sounds funny, but it was not so easy. We have been, during 1 year, all disciplines agree and understand what is the objective that we want to achieve with the model or with the work that we have done, because then you can organize the different needs for the model.
That again sounds simple, but sometimes. Yeah. There's another question I really like from the audience here. How were non-technical factors like social acceptance, environmental constraints incorporated into the multi-criteria concept evaluation?
We have been included originally when we defined the first was the goal, what we want to achieve, and then we define strategies, what we want to, how we want to achieve this, and in this was included potential limitations or needs for the social acceptance or for the environmental point of view. We included implicitly from the beginning in the definition of the strategy, in which is based the concept model that we finally modeling in Petroviar.
Right, right.
It was
And
an
in general,
exercise from the beginning. From the beginning, sorry, the preliminary phase of the strategies and defining what we want to do, all the team have been together: technical, legal, environmental, social acceptance, economical. Everybody was agreed on the way and considering all the different factors. That is very important.
Right. That's interesting to me. I mean, especially curious about the social acceptance factor or point, because I have the sense or the feeling that sometimes when we talk about CCS with, regular citizens, they are not very aware of it. I don't know if you have the same, let's say, findings, or do you think CCS is something that is well known by the people?
It is not. It is not well known. We have been working, we are very lucky because here one of our partners, CIEMAT, they have an excellent team working for 20 years in social acceptance, also in CO2 storage, and they help us. We work together to consider the social acceptance and social license from the beginning of the projects. So we have been in this from almost 8 years, and they start, and the pilot strategy is a very good example. They start understanding what is the knowledge of the people, but also going through the project with the stakeholders group. So what we did was every 6 months, we have a group selected from the area, from the administration and different type of areas of the society, local and regional, and every 6 months we have been with them explaining step by step the different aspects of the CO2 storage, risks, geology, MMB, understanding what they were their concerns and trying to answer their questions. Not convince, explain from a technical point of view what we do for avoiding anything that they can be worried about.
Right.
It's an exercise needed and takes time. It's a long way process, but it's absolutely needed.
Necessary, yeah, you're right. Yes, I agree with that. So let me check here for, I think I have one more question from the audience. It's about Petroviar. Which visualization or reporting features in the software prove most effective for communicating results to decision makers and external stakeholders?
I think that for external, the best thing is the more simple one. I think that it's more important, instead of having a lot of different graphs and charts and so on, just going to this one that are the most simple that as possible. There is one that I really like when we analyze the impact of for example, the geological risk or the commercial risk and so on. There is one specific that is about a cluster that can explain how is the economic results or the delays and so on in each of the cases. So that, at least in my case, I give us a lot of I see very complex in the context, but very easy to see to the others, and also for comparing scenarios or different cases. There is some specific charts that are in the Petroviar now that they are very, very useful.
Yeah, no, I agree with that. I think it's not easy to find tools out there that really simplifies capturing and basically running probabilistic type of calculations and and then exploring and make analysis on the results. I think our development team has put a lot of effort into that particular capability in the software, which makes it great for this type of projects, right? All right. Good. So right, I'm conscious of time. We have 5 more minutes left. So what I'll do now is, before concluding, I would like to quickly present one of the Quorum announcements of the QNX series in EMEA, which are the QNX Global events designed for energy professionals to connect, learn, and discuss industry innovations across upstream, midstream, and measurement sectors. If people in the audience would like to engage with us, feel free to scan these QR codes that you see on the screen. We're having 3 events by the end of the year. You see in 3 different locations: Abu Dhabi in October 8th in the St. Regis Great Hotel, and then in September 24th in Stavanger, the Hotel Victoria. And also we are hosting one in Aberdeen, October 1st in the Sandman Signature Hotel, very emblematic building. So feel free to scan these QR codes and participate and stay connected with us. Well, and thank you very much, Paula, for joining and providing all these very insightful details about all your work. I'm looking forward to see these projects materialize, these different initiatives. Very, very useful, I think, and needed, especially in this, in this era, right, where we're seeing different challenges that we need to solve. I think CCS provides a really good solution for multiple challenges that we have in society. And thanks for the attendees for coming and sharing your questions and time with us. Please remember that a survey will pop up at the end of this, and we really appreciate your feedback. Watch for that email that we're going to send you with a recording of this webinar. And of course, it will be also available in our website at quorum.com. Thank you very much. Thank you, Paula.
Thank you. Bye-bye.
Have a nice day.
The same.
Bye-bye.